Okay, in this video we will try to develop the pseudocode for merge sort algorithm. Okay, so just to recap, like what we did in my previous video, where we started with this particular unsorted array, right? And then we use the merge sort technique to sort this one, right? Now while doing that, we follow two very broadly categorized steps. Like one is the divide part. Over here if you see that this colorful part is the divide part, where we have divided this whole array until and unless we are getting fully sorted arrays, right? And then we were applying the merge sort algorithm, basically to the merge sort technique to sort those arrays, basically to merge those two sorted arrays, and finally we got our full sorted arrays, right? So we will try to develop the pseudocode for these two steps. One will be the merge sort, and another will be the merge one. Okay, so if I just write it down over here. Okay, so let me create a table over here. Now the two techniques, or the two pseudocodes, I'll be dividing this whole pseudocode building stuff into two very broadly categorized stuff. As I said, one will be dealing with the division part, another will be dealing with the merging part over there, right? So we will name them as merge. Okay, merge. Let's say we'll have an input array A. I'll define everything, and I'll be giving whatever I am doing it over here through examples. Okay, and P comma Q comma R will be the indices of that array. Let me first write it down over here, then I will explain it over here. Okay, now another algorithm we'll be developing, another pseudocode we'll be developing. For this one we'll be using for the merging part. Okay, so this video we will concentrate on building this one. In the next video we will try to concentrate on the division part. So we'll name that pseudocode as merge sort. Okay, A comma P comma R. So where PQR is always indices over here. Okay, so let us try to focus on this merging part, where we will be taking an example of, let's say we will be taking example of these two guys, merging these two guys into a single array over here. Okay, so if you see the pseudocode merge is taking an input array A. That means in A there will be a two sorted sub arrays, 2 4 5 7 and 1 2 3 6. So let me try to set what A is. Okay, so my A will be, so if I just write it down over here, my array A will be, so it will be 2 comma 4 comma 5 comma 7. Okay, comma 1 comma 2 comma 3 comma 6 over here, right? So this will be my input array. Now if you see, it has two subarrays, 2 4 5 7, which is already sorted, and 1 2 3 6, which is already sorted over there, right? We are going to merge these two into a single subarray over here. Now when we will be merging this one, we'll be replacing element of A with those ones. So that means whenever I'll be placing 1, I'll be placing 1 at the first element of A. When I'll be placing 2, I'll be placing 2 at the second element of A, something like this. Okay, we'll not be creating another array to replace that one. So we'll be replacing the existing array only. We will see how we are going to develop it. Okay, now let us try to define PQR. Okay, now as I said, P comma Q comma R are indices over here. Okay, so indices of the array, basically such that P less than equals to Q less than R. Okay, so that means if I just write it down over here, so if I just write it down for our array, so the value of P will be 1 over here, right? So if I just write something like this one, so the value of P will be 1 over here. So that means the first element over here, right? And the value of q will be over here. So if I just say I divided this particular array into two sub arrays, right? 2 4 5 7 and 1 2 3 6. So q will be 4 over here, right? So till 7 over here, and r is the last element indices. That means total we have total 8 elements over here, right? So that means r will be 8 over here. Okay, so basically we are taking the indices of these two sub arrays over here, right? If you see the first element, the last one, and the where we are dividing over here, that is represented by q over here, right? Now if I just write it down, now the merge, this merge particular pseudocode, it assumes, okay, so that a p to q, okay. So if I just write something like this one, this is p to q, okay, this will be sorted as well as, and a q plus 1, that means from this element, fifth element in our case, right, to r, these two sub arrays will be sorted always, okay, in sorted order, will be sorted order, okay. So as we have taken in similar way only, right? So that will be the one. And what it does basically, so let me write it this way. So it merges them, right? Merges these two sorted sub arrays, okay, to form a single array, okay, which is this one in this case, right? Because we are taking this two array and joining them together to make this a over here. That's why we are saying this sub arrays will be always sorted order, okay. To make a single sub array, like single array basically, and that replaces the current, let me go to the next line, current array over here, okay. So which is a in this case over here, we're going to replace a over here, okay. That is what I have written it over here. So if I just write it down in mathematical term, so this will be a p to r, right? Because r is the last indices over here, right? So that means we are going to take this two a p q and a q plus 1 to r sub arrays, which are already in sorted order, and we are making a final array called a p r over here, okay. So now if you remember from my previous video when I talked about the intuition behind the merge sort algorithm, right, over there we have discussed like how we are going to sort it, right? Because that time these two sub arrays we have taken in a left hand and right hand vertical arrays, right? And then we compare element by element wise over there, right? So we are going to develop the pseudocode accordingly, like that only, okay. So that means the first thing we will do is we will basically arrange these two sub arrays into vertical arrays. That means left hand array and the right hand array over there, okay. Then we will try to write the comparison code over there. So let me create two vertical tables over here, and let me arrange it for that, for this numbers over here, okay. So as you see it over here, just like we did in our previous video, right, this 2 4 5 7 and 1 2 3 6, I have arranged them in a vertical order, right? So the order, maybe you can give either top down or bottom up approach, anything you can follow, that does not matter, because at the end of the day you are comparing from the left hand side array with the right hand side array over here, right? So we created two sub arrays and just stack them in a vertical manner, okay, into a left hand array and the right hand array over here, to those two sub arrays over here. Okay, now let us try to do some basic math over here, then we will gradually develop the algorithms over here. So if I just say, like, what is the number of element over here in left hand array over here. So if I just write that number as in 1 over here. Okay, so what is the number of element over here? As you know from the basic math itself, we know the last indices minus the first indices plus 1, right? So if I just tally it over here, so we have value of q is 4, right? That's this 2 4 5 7, right? That means 4 minus 1, that is 3, plus 1, that is the number of elements in 2 4 5 7 in our left array, right? So if I just say n1 equals to number of, I just write hash as number of, or let's say number of element in left array, okay, which is nothing but q minus p plus 1, right? So this is the number of elements in our left array over here, right? Now similarly, if I just define in 2 over here, which is nothing but the number of element in right array, okay, in right array, which is again, if I in our right array, it starts from q plus 1, right? This particular is the fifth element, that means q plus 1 till r, right? That means the last index basically, minus the first index, that is, which is nothing but q plus 1, right? Then plus 1, so that will be our total number of element over here, which is nothing but r minus q over here, right? R minus q. So if I just write in a next line, okay, I'll just come back till this point, which is nothing but, let me arrange in proper way. So it will be r minus q minus 1 plus 1, minus 1 and plus 1 will be cancelled, so it will be r minus q over here, right? That is the number of element we have in our right array, correct? Now so if I just now define, okay, let me change the color and go down as well a bit, so that we will get a space over here, okay? So if I just define L as my, maybe this color is not good. So if I just define L as my left array, okay, left array, and R as my right array over here, okay, left hand array or right hand array over here, okay. So that means this L is, if I just say it, L, if I say it in terms of indices over here, 1 to n1 is my left hand array, correct? So if I just copy it over here, Control X, so that is my left hand array over here, right? And if I bring it down R, so R will be nothing but R 1 till n2 over here, right? Now think about it. If we just recap what we have done in my previous video, what we have done, we are basically comparing. We are taking one element from here and one element from here, comparing them, which one is smaller. We are replacing the first element of A over there, right? And then when we are replacing that one, we are removing from this deck over here, right? So that means it is exposing a new card over here. Then again we are comparing which one is smaller, we are taking it again, right? So until and unless one deck is empty, we are continuing this one over here, right? Now whenever we are building this particular pseudocode, we also have to know when the deck is getting completed, right? So whenever deck is getting emptied, we are just taking the other deck fully and just keep it over there, right? Because these two decks are already in sorted order over there, right? So we have to know somehow whenever a deck is getting emptied over here, right? So for that, because we'll be dealing with pseudocode over here, right? So we need a condition over there, right? So generally that's the reason we include an extra element over here called sentinel over there, and the value of the sentinel will be generally infinite over here. That means whenever our infinity card is getting exposed, we know like we have completed that particular stack over there or deck over there, right? So that we can place the other stuff as is, okay, in that array over there. So for that, what we'll do is I will just add a extra element over here to this left and right hand arrays, sub arrays basically, called infinity over here. Okay, let me do that one. So if you see, I just added this particular element to these two arrays over here. Okay, so now this left hand array will having an extra element over there. So that means the size of my left hand array will be n1 plus 1, right? And from 1 to n1 plus 1, where n1 is the previous number of element plus 1, right? And similarly our right hand array size will be 1 till n2 plus 1, correct? So this is how our new sizes will be coming, right? So now first thing we have to do, because we are writing the pseudocode, right? So each and every operation we have to do it. So that means first we'll write a code to fill up this left hand array and the right hand array. Okay, then we will try to write a code for the merging part. Okay, so for that, first we will see how we can write a pseudocode for left hand array and right hand array. So for that, we have to do a looping over here, right? So we will do looping for first, if I just write the code for left hand array over here. So we will first loop till 1 to n1. Okay, we will fill it up, then we'll just write a code n1 plus 1 will be always infinity. That means last element of these two arrays will be always infinity over here, right? So let us do that one. So we'll just go up a bit. So we'll write for, okay, so let me change the color. For, okay, I equals to 1 to n1, right? So till this n1 we are looping into, right? So let me go do like this one. Then what will happen? So that means I am looping through this 4 elements over here. Now currently I am filling up the left array over here, right? So if I just write left array, so if I just write left array I, okay, will be which one? So if I just write it down, a I over here, let us see whether it is making sense or not, right? So I means I am looping through the indices of this left array over here, right? That means 1 till 4 over here. So a also have 1 till 1, 2, 3, 4. This 4 indices has this 2, 4, 5, 7 only. That means I'm just simply putting li equals to ai over here. That means the first 4 elements of a basically will be copied into the left array over here. Okay. Now let us similarly develop the pseudocode for right array as well. Okay. Let me change the color as well over here. So we'll write for, okay, again j equals to 1 to in 2 over here, right? So we are looping with this 4 elements over here, right? Now right hand sub array j will be, now which portion of the a, that means we will be starting with whatever, we'll be starting with q see, if you see this 1, 2, 3, 6, their indices are 5, 6, 7 and 8, right? That means q plus if you see q is 4 over here, that means q plus 1 plus q plus 2 plus q plus 3 plus q plus 4 over here, right? That means I'm talking about the indices, not the data over here, 5, 6, 7, 8, right? So that means j is actually looping through 1 to 4. That means if I just write a q plus j over here, that makes sense, right? Because this one is actually looping from 5 to 8 over here, and q is 4. That means 4 plus 1 is the first element, 4 plus 2 is the second element, something like that, right? So this is how we are filling up the right array over here. Okay, now we still not finished filling up left array, because you have to add this guy over here as well. We will write L, okay, in 1 plus 1, that this the last element of a L, sorry, not a, will be infinite. Okay, similarly for right hand array also the last element will be infinite. R in 2 in this case, right, plus 1 will be also infinite. Now we are going to develop the pseudocode for the comparison purpose over here. Okay, so for that what we'll do is we will just initialize this I and j, because we are going to reuse these two indices variables over here. Okay, to 1, so I equals to 1 and then j equals to 1 over here. Okay, this is just reinitializing that one because we are going to reuse them. Even you can choose any other variables over here as well, but that will take more memories, right? So that means we are going to, because these things already we have used to fill up the left hand and right hand array, so they have do not have any other use when the program flow will flow to this particular line over here, right? So we reuse them, so we have, that's why we have initialized them to 1 as well. Okay, so now let us going to fill up, let us going to compare and put the elements in A over here. Okay, so if you see if I just going to compare the first element of left to the first element of right, so the right element is lesser over here, right? That means 1 will be going to the first position of A, right? That is what we have discussed previously over there, right? So if I just write that logic over here, so what we'll do, we will go another loop basically, which will loop through all the elements of A. Okay, so if I just say k, another variable over here, equals to p, that means the first indices of A, to r, right? That is the last index of A over there, right? Now we will do the comparison over here. So we will write if, correct, left hand subarray, that is the I, that means we are basically starting with the first element of left hand subarray, which is in this case 2 over here. Okay, is less than equals to right hand array first element, which is basically j over here. That's why we have initialized I and j with 1. So we are always starting with the first element of left hand array and the right hand array. If this is the case, okay, if this is the case, so what we'll do, if it is less, then the first element, that means the value of k, right? Because k is looping through all the elements of A over here. That means first element of A to the last element of A over there, right? So I'll write something like this one. So we will write A k equals to, okay, left hand, sorry, it will be capital L, left hand I, left array I. That means because as left hand because of these two elements, between these two elements, if this one is smaller, this one will be the first element of A, right? That means that particular element of A, if I just talk about the first one, it will be the first. If I just talk about the second one, it will be the second one, right? So that means we are basically replacing that element of A with that element of left hand array over there, right? And then when we have done that one, right, so that means we have placed an element from this array to A. That means I have to go to the next element, I have to expose the next element over here. That means I have to increase the I over here, right? So that is what we'll be writing it over here again. So I equals to I plus 1 over here, right? So after placing an element in A, we are just increasing the value of I. That means exposing a new element of that particular array. Now if this is not the case, which is currently our case, because our left hand subarray first element is not less than the right hand subarray first element over here, right? So in this case, what I have to do, our AK value will be the right hand value only, right hand subarray value only, right? So that is what we are going to write it now. So we'll write else, okay? So else what will happen, our value of AK, okay, AK will be our right hand array, that particular element over here, right? So RJ, correct? So this is the current element, and when we place a right hand subarray element, right? So over here we are placing the left hand subarray element into A. Over here we are placing the right hand subarray element into A, right? So now when we are after placing it, we are increasing I over here. In this case, we have to increase J over here, right? Simple logic. So we'll write J equals to J plus 1, right? So this is how this whole particular looping, and so this is what the pseudocode for the merge part. That means this particular part over here, we have just taken an example of this two subarrays over here and merging them. This is going to hold for this particular merging as well, right? So if you see, we are doing the merging part again and again. That means there is a recursion works over here, right? We will develop that recursion part in the merge short portion over here. We have still not finished the whole pseudocode development. We just developed the single part, okay? In the next video we'll see the merge short part as well, okay? So that means if I just ask you over here how many basic steps we have performed over here, it will be r minus p plus 1. That means the number of elements over here, right? So if I just write it down, if I just go a bit up over here, the number of basic steps we perform while doing this particular merging is r minus p plus 1. That means each and every loop portion, because this loop is moving from A to P to R, right? That means for each and every loop iteration, either we are placing that left hand subarray to A or right hand subarray to A. That means when the loop will be ending, we have just our array will be already sorted over there, right? That means we will be placing all the elements of left hand and right hand subarray to A. Now while doing that one, suppose we are exhausting the right hand array over here, right? So that means in that case our infinity card will be exposed over here. Then whatever element we have in our left hand array, or similar logic will be applied for left hand array as well. If left hand array is getting finished, right, that means our infinity card will be exposed over here. In that case, whatever left in that right hand array, it will be placed accordingly, right? Because in that time, if you compare any element of right hand array which is not infinite to this left hand array infinite, that will be always small over here, right? So that means this code will be working, right, in that case. So similar logic, either this code or this code will be working in that scenario, and it will be placing that element accordingly over here, right? Okay, so let us try to build the second part of this one, that means the build the merge sort part in next video. Okay, see you in next video.